Remember, first of all, that there are three elements in a percent sentence. Can you remember what they are? We have the whole amount, part of the whole, and last, and certainly not least, we have the percentage. Let's also review what we mean by a proportion. That's an equation that asserts that two ratios are equivalent. For example, John's hat size is to John's shoe size as Sam's hat size is to Sam's shoe size. This asserts that when I make that fraction, the fraction is going to be the same for John and Sam. And we're saying that there's a relationship between hat size and shoe size that scales between people in this particular case. But a proportion is two ratios that you set equal to each other. Let's remember something else. The way you solve ratios, if you actually go through the mathematics, what you find is if this proportion is correct and you cross multiply, A times D is equal to B times C. If the proportion is correct, then that cross multiplication is also necessarily correct. Also, we see for a proportion, if you know any three of the four different pieces of the proportion, you can solve the proportion. If you know B, C, and D, you can get A, and so forth for all the pieces of the proportion. Oh boy, what a word. If we know three of the terms, we can calculate the fourth. Now let's just review percent. Remember that we can express percent effectively as a ratio. N% is N over 100. That's actually a ratio. Let's look at something else. We can also say that, remember that the part is the percent times the whole. For example, if I had 50% of 30, the part of that is 15. Half of 30 is 15. Looking at the math, I can also see here that the percent is part of over the whole. Therefore, I notice something. The percent is the part, like the 15 over the 30, and percent by definition is N over 100. I have two things equal to the same thing. Both of those are equal to percent. Let me set them equal to each other. If both of those are equal to percent, then they're equal to each other. And when we set them equal, we have a proportion. N, the percentage that you're given, is to 100 as the part is to the whole. This lets us solve percent problems that are similar to the ones that we've done in Unit B. Let's take a look. 20% of 460 is what number? Just to review, remember we see the word of, and the whole amount is what follows the word of. You should keep that in mind as you do these things to identify which is the whole and which is the part. Often by looking at the numbers, it's not always clear. Generally speaking, the whole is larger than the part. But if you're dealing with a part being 150% of something, bigger than the whole, that might be reversed. The best thing to do is to try to see where the of is and use that for identifying the whole amount. Here's how we set this up then. Remembering this ratio, N is to 100 as the part is to the whole. Now we have this simple word sentence. 20% of 460 is what number? Since we have 460 following the of, that must be the whole. We see that N is equal to 20. In this case, we don't have to change the 20% to a decimal because N is defined as the percentage. We have now the proportion 20 is to 100 as the part is to the whole. Let's continue with the math. 20 is to 100 as the part is to the whole. What we do next is cross multiply, and we're left with the equation. I'm going to call the unknown part x. We're left with the equation 100 times x is equal to 20 times 460. This is a relatively straightforward equation that we can solve. We'll solve it on this screen. The first thing I need to do is to simplify the quantities on the right by performing the multiplication, and I get that 100x is equal to 9200. What should I do next? I need to get x by itself. Let me divide both sides of this equation by 100 to get x by itself. I see on the right I have 9200 divided by 100. Let me do this. I see I have 2 zeros in the 9200 and the 2 zeros in the 100. That is effectively canceling those out is the same thing as dividing the numerator and denominator by 100. When I solve for this, I get that x is equal to 92. Therefore, we can say that 92 is 20% of 460. Here's another case. 70 is 20% of what number? What are we looking for here? What we're given of what number? What number must be the whole? Meaning, in this case, we don't know the whole thing, but we're given the percentage and the part. There is our proportion. N is to 100 as the part is to the whole. Let's plug numbers into that proportion. 20 is to 100 as 70 is to, again, in this case, we don't know what it is. Let's give it a name, call it W for whole. Let's go here, and the next thing we do is cross multiply. 20 times W, that's taking the top left, bottom right, equals 100 bottom left times top right. We're left with the equation by cross multiplying 20 times W, the unknown whole, is equal to 100 times 70. Let's work on this equation here. First, we multiply 100 times 70 and get 20W is equal to 7,000. Divide both sides by 20 to identify W by itself. In this case, I have a 0, and I can divide the 7,000 by 10 and the 20 by 10. And when I solve this, 700 divided by 2 is 350. I can say that 70 is 20% of 350. Let's look at this one. What percent of 200 is 30? I plug in now. 30 is the part, 200 is the whole, and in this case, I'm looking for a percent. How do I do this? What's my next step? I need to cross multiply. What should I get for the term on the left? 200 times n, top left, the numerator of the left-hand ratio times the denominator of the right-hand ratio is equal to the opposite. I get 200n is equal to 100 times 30. And there is my basic equation, 200n equals 3,000. I now solve this for n the percent by dividing both sides by 200, canceling out the zeros, and I find that n is equal to 30 over 2. I get this by dividing numerator and denominator by the common factor of 100, as is shown by those two zeros. And I find out that n is equal to, you get n equal 15, but look at the question. It says, what percent? When you report this, you have to report it as a percent. I would answer this by saying that 15% of 200 is 30. And I've solved this. Notice that I'm developing a pattern here. What I'm doing is looking at these problems piece by piece. The first problem dealt with finding the part. The second problem dealt with finding the whole thing. And the third problem dealt with finding a percent. We'll continue this cycle with another problem in which we're looking for the part. 0.5%. Notice you have to be careful here. It's not 5%. It's 0.5% of 1,234 is what number? Since we have of 1,234, we can assume that that's the whole. We're dealing with 0.5%. I get the proportion 0.5 is to 100 as the part, the unknown, is to 1,234. Took a lot of originality to come up with that number, didn't it? At any rate, let's work on solving this. We cross multiply and get that 100x, I'll call the part by the unknown x, is equal to 0.5 times 1,234. Remember also, what does 0.5 represent? It represents a half. Here's the equation. 100x is equal to 0.5 times 1,234. Let's do the math. Half, remember 0.5 is half, of 1,234 is 617. I have 100x equals 617. Dividing both sides by 100, I get that x, the partial result, is equal to 6.17. Notice that when I divide something by 100, divide 617 by 100, there are two zeros in 100. I can look at a shorthand way of doing this. If there are the two zeros in 100, that tells me to start with the decimal point over to the right of the 7 and move it back 2 spaces. 617 divided by 100 I can do in my head now and know just by moving the decimal points that must be 6.17. We can complete this sentence now and say that 0.5%, 0.5% of 1,234 is equal to 6.17. Let's go on to the next problem. In the last problem, we looked at the part. Guess what we're looking for now? 85% of what number is 352.75? We set the proportion up. Again, I'm writing it out just as the definition, so it's always in front of you. And now let's plug the numbers in. N is equal to 85, so I have 85 over 100. Incidentally, using the same rule that I told you about before, if we wanted to express 85 over 100 as a decimal, what would that be? It would be 0.85. Remember, n over 100 is the percentage, and if we have 85%, the decimal equivalent is 0.85. The whole thing just ties together. Then that, by proportion, must be equal to, we're given the part, 352.75, or if you want to think about this as money, $352.75, and we're looking for the whole thing. For example, if you were doing a problem like this, you could say some appliance has been reduced to 85% of its full price, and you might ask what the full price is. That's what we're calculating here. What's the whole thing before it went through the 85% meat grinder? We have an equation here. We have a proportion. What do? We'll cross multiply. 85 times n is equal to 352.75 times 100. Working on that, I get 85n is equal to 35,275. Notice that I go the other way. In a previous problem, when I divided something by 100, I moved the decimal point 2 places to the left. When I multiply something by 100, in this case, I moved the decimal point 2 places to the right. That's useful information. If you were multiplying by 1,000, for example, you would move it, there are 3 zeros in 1,000, you would move the decimal point 3 places to the right, and oppositely if you were dividing. Let's continue with the problem, though. Here's the equation. Let's solve the equation by dividing both sides by 85, and I find that the number I get is 415. 85% of 415 is 352.75. You can also look at this in terms of reasonableness. 100% is going to be 415. 85% is going to be most of it. Then I look at my answer and I see, sure, 352 isn't that far off from 415, and that gives me some confidence in my answer. If I got 35.2 and I saw that that had to be 85% of 415, I would start to doubt it. I would start to think that there might be a problem. Always look when you're doing these things for the reasonableness of your answer. If your answer is somewhere between 45 and 60%, if you're looking at percentages between 45 and 60%, you're looking at about half. If you're looking at percentages around 25%, you're looking at about a quarter. Use the idea of reasonableness as a way of checking yourself. Is my answer reasonable? And use the idea of the percentages being close to 100%, close to 50%, close to 25% as a way of doing the math quickly in your head to check to see if your answers are in the right ballpark. And as I said, in this case, we say that 85% of 415 is 352.75. So if we were dealing with an appliance, the original price of the appliance would be $415. Here's a problem. We're asking, what number is 150% of 72? What number is 150% of 72? In this case, what are we looking for, the part or the whole? We see the of 72, so 72 must be the whole thing. Therefore, we must be looking in this case for the part. Here is our basic equation, and in this case we have 150%. I have the now improper fraction 150 over 100 is equal to the part, which is what we're looking for. I'm going to call it n over 72. Just looking at this proportion, you see that 150 is greater than 100. What should that tell you about the n? The n needs to be greater than 72. When we now do the math, we can cross multiply 100n equals 150 times 72. Doing the multiplication, I get that 100n is equal to 10,800. Let's solve this for n, the part of the whole. When I do this, I see that I have to divide both sides by 100. Fair enough. I see I have 10,800 with 2 zeros and that 100 with 2 zeros. I take the shortcut of dividing numerator and denominator by 100 just by crossing out the zeros, and I find that n equals 108. I can say then 150% of 72 is 108. Here's a case where the part is greater than the whole because the percentage is greater than 100%. you have to be careful. The smaller of two numbers isn't always the part. It could be the whole thing, depending on whether the percent is less or greater than 100%. In this case, since we had 150%, the part of the whole was actually greater than the whole by half. Here is extending our idea. Let's take what's 20% of 5/8. We can use the same technique even though we're looking for 20% of a fraction. This is a case where we're going to have to do a little bit of extra math, but it's doable as long as we remember the rules and apply those rules step by step. When you see something like this, it may throw you because, wow, that's a situation I haven't run into before. What do you do about 20% of a fraction? How do you handle that? It's 20% of 5/8. Woo. And the way you do it is not to panic. You proceed step by step and you ask what at every step is good math. Let's apply good math to this. 20 is to 100 as our unknown is to 5/8. Here we're just repeating the equation, and now let's do this. What would be the next most natural thing that you're going to do? Let's cross multiply. And we get 100 times x, and I'm going to use x as the unknown for the part that we're looking for, is equal to the quantity 20 times 5/8. In this case, I have a multiplication that involves fractions. Let's work on that multiplication. What's 20 times 5/8? Then, once we do this multiplication, we'll go back, plug it in, and continue working the equation. 20 times 5/8 is equivalent to the 20 over 1, expressing 20 as a fraction, times 5/8. When I do that, I find that 20 times 5/8 is 100/8. 20 times 5 is 100, 1 times 8 is 8. Now we write the equation. 100x equals 100 over 8, or 100/8. If I want to, I can express 100/8 by dividing 100 by 8 and express that as 12.5. At this point, it might be easier to continue doing the equation that way. When I do, I have to solve 100x equals 12.5. Dividing both sides by 100, I find that x is equal to 0.125. Good answer. But let me play some more. Unless you're specifically told that you need to express your final answer also as a fraction, you can stop here. But you don't have to stop here. Let's now go actually try to express this as a fraction. What we have is 125 thousandths, indicated by that decimal. Let's rewrite that in fractional form. 0.125 is equivalent to 125 over 1,000. Now all I have to do is simplify that fraction, reduce it to its lowest terms. I notice that I can express it this way. 125 in the numerator is 1 times 125. The denominator, 1,000, is 8 times 125. I can cancel out the 125s and express the answer to this problem alternatively as x is equal to 0.125 or x is equal to 1/8. Once you've been using fractions and decimals a bit, you will automatically recognize some of these more common ones, and 0.125 is recognizable as 1/8. I probably wouldn't have had to do the math having done a number of these. I just see that. But by using the rules, again, applying what you know in terms of the definitions of decimals and so forth, it's always possible to work your way to the answer you want. If in doing a lot of problems you learn the shortcuts, so much the better. Let's look at another one. 0.23% of what number is 64? By the rules, 0.23, notice it's not 23%, it's 0.23% equals 64 over the whole thing, which we'll call n. When we cross multiply this, we get 0.23n is equal to 64 times 100, or 0.23n is equal to 6,400. Next, we divide both sides by 0.23. When we do the math now, probably using our calculator, what we find is that our final result, the whole thing, is 27,826.1, rounding it off. Or we can state this at 0.23% of 27,826.1 is 64. This is the last problem we're going to do in Unit C, and I'm not going to work the whole thing. I'm just going to set it up for you. What percent of 2/3 is 1/16? We use the same formula. We don't know the percent, and we say that n is to 100 as 1/16 is to 2/3. Remember, that really means 1/16 divided by 2/3. We write this as an equation, but now let's simplify the 1/16 over 2/3. That really means 1/16 times the reciprocal of 2/3, 3/2. When I do this, I get n over 100 is equal to 3 over 32. And I'm going to leave you here. I now have a relatively simple proportion for you to solve on your own. I'm sure you'll be able to do it.